Alrighty, this is an algebra review for all of chapter 2. Starting off, we're going to be covering polynomials. I'm using my blue marker because my black one's dying. So a polynomial would be anything in the form of ax, like squared, plus bx plus c equals 0. So it's all these. You have quadratic, or you have it's quadratic. You have cubics also. Got your ax cubed plus your bx squared plus your cx plus your d equals 0. So it's just anything where you have ax to the n plus bx to the n minus 1 plus cx to the n minus 2, and so on, all set equal to 0. So the way you're going to go about solving a polynomial equation is first you're going to isolate all the variables onto one side. So that could be, for example, x squared plus 3x equals -2. Look here. You can't really solve this as you still have a number over here and that's not 0. So what we have to do is add 2 to both sides. And then from here, what we can do is factor, which is like what you learn like Algebra 1, and it's, you take the 2 numbers here, multiply to your a value. You take these 2 numbers here, multiply and get your c value, and then you multiply this number times this number and this number and then this number to get your b value. It's called foiling. First, outside, inside last. And in this case, it's x plus 2 and x plus 1 equals 0. And then if you remember the law of zero products, we can say that means that x equals -2 or x equals -1. This is a very simple example. Harder. Excuse me, it can get harder. But one way that we can look at an extremely similar equation, go with, also make sure I use these to make it easier to tell where the variables are. 3x squared equals -2x minus x cubed. And so what we're going to do here is set it up so that the coefficient of the largest x value is positive. So that means we have to add x cubed to both sides. So we get rid of the negative x cubed over here and we have instead a positive x cubed over there. Oopsies. X cubed plus 3 squared equals -2x. And then we can do the same thing again where we add 2x to both sides. So we get 0 on the right side. We get x cubed plus 3x squared plus 2x equals 0. And then from here we can also look and figure out what common factors are shared by every single number in the polynomial. And if they share any common factors, you can factor that out. And now we're left with a much easier to deal with polynomial, which is the same as what we were just working with. Now we can factor this inside the polynomial just the same. And so using the law of zero products, we also have the -2, -1 from earlier, and we also have the 0 from what we factored out. These can still we ramped up yet another level. Let's see what's a good example. Ooh, here's a good one. X to the 5th plus, what would that be? Oh, minus 10. That should be blue. Minus 10x cubed. Is that minus or plus? Plus 9x. And so you're looking at this like those those exponents are too big for any method we've used so far, and you would be correct about that because even after we factor out x, we would still be left with x to the 4th minus 10x squared plus 9, 0. But one really clever trick that we can use is then use substitution. And substitute in over here and say that x squared equals this new variable we'll call u. And now we can substitute that in and we're left with x times u squared minus 10u plus 9 equals 0. And then this we can factor. Factoring for this will be u minus 9 and u minus equaling 0, which means so far we've established that x equals 0, x equals 0, and over here I'll write u equals both 9 or 1. And so what the implication of that is that since we're trying to find x, we can then use substitution back in and say that x squared equals 9, and additionally x squared equals 1, and then we can then from that say x equals plus and minus 3, as well as saying x equals plus or minus 1, which leaves us with all of our solutions. And if we check, this follows the fundamental theorem of algebra. There's 5 here to the equation. Because it's degree 5, we got 1, 2, 3, 4, 5. That's about as complex as polynomials with factoring are probably going to get. And then the next will be rational equations. And so what a rational equation does is it takes x and puts in the denominator somewhere. So a really, really simple rational equation would be something like 1 over x equals 9. And then multiply both sides by x. Divided by 9, we get x equals 1/9. But that's way easier than what we're looking for. We're going to be looking for something a bit more complicated. Let's see what we got. Alright, here's a good one. 1 plus 12 over. Alright, 1 plus 12 over x squared minus 4 equals 3 over x, and that's minus 2? Yep, minus 2. And so, before we start the equation, before we do anything with it, what we're going to want to do is factor the denominators. And then that leads us to the difference of squares. And I did not get myself enough space for that. But it's a difference of squares where the squares are x squared and 2 squared. And if we remember difference of squares, it's x plus 2, x minus 2 equals 3 for x minus 2. Now that we have this, there's something we have to establish. And that is the cases where x doesn't exist or can't equal. And so that's going to be whenever it makes the denominator equal to 0. So here we have over here negative 2 and 2 make this denominator equal to 0, and 2 over here makes this denominator equal to 0. And since we can't divide by 0, those cannot be solutions. So we can mark off 2 and we can mark off negative 2. And so then what we can do is find the least common multiple of all the denominators. In this case, it's going to be x plus 2, x minus 2, because this is a factor of that. And multiply the entire equation by that, so we don't have any denominators. Oopsies. And so this is where we've got 10. Once we multiply out all the denominators, we can simplify this further into x squared minus 4 plus 12 equals 3x plus 6. And then from here, we can, I'll just continue over here. We can simplify this down further by like combining like terms and shifting everything over to the left side. We're able to get x squared minus 3x and then plus 8 plus 2. That looks right. Yeah, but I can add numbers on the equals 0. And then from here, it's extremely basic. Factoring x minus 2, and then x minus 1 equals 0. Therefore, x equals 2 or 1. But if we look back here to what x cannot equal, one of those is 2, which means we cross this out and then just say x equals 1. And I think that's basically just the gist of it for rationals. Just find a common factor everything. Consider the cases where the equation is undefined, and then find the least common multiplier, turn everything into a numerator, and then solve it like a polynomial. Then next we're going to cover inequalities. First, we're just going to really quickly go over solving just a very basic inequality. So 7x plus 3 is less than 9x minus 10. And so this is just going to be solved like your run-of-the-mill linear equation. Add 10s to both sides, subtract 7x, you get 13 is less than 2x, and then 6.5 is less than x. And then you can turn this into interval notation, and you got 6.5 all the way to infinity. And that's just that for a very basic linear inequality, but it's not that simple. some types of inequalities we're going to look at are first going to be just inequalities where you use your intuition primarily. So let's go with x squared, is greater than or equal to 4. What we can figure out here is that, well, think about what two things squared equal 4. And so we can consider it's going to be x is going to be able to equal to a negative 2, since this is greater than or equals to. And then consider the behavior as they go from one side to the other. So if we consider growing bigger, x equals 2.7, 2.7 squared is also bigger than 4. So we could say x is greater than or equal to 2. And then if we also look what happens if we consider the behavior as negative 2 gets bigger, well, we got negative 1, but that squared is less than 4. So we go the other way, negative 3. Negative 3 squared is greater than 4, so it's going to be x is less than or equal to negative 2. Interval notation, we're going to use negative infinity. Oops, oh, forgot that in the last one. X is an element of, just because it sets negative infinity to negative 2, bracket because it's or equal to, union with 2 to infinity. And then once you get past just these, where you kind of just look at it and get it, then you can actually go into ones where you can actually do math. And let's consider a case for this. This case will be x squared minus 5x plus 4. Yep. Yeah, and so then what we can do from here is greater than 0. What we can do from here is factor it. X minus 4, x minus 1 is greater than 0. What we really want to do here is get out a number line, and then on the number line mark the important spots. So that would be when it's equal to 4, because that's when this would be equal to 0, that's pretty important. Or when it's equal to, or when we have 1, because that's the other time that it's equal to 0. We can label these sections as 1, 2, and 3. Use Roman numerals so I don't get them confused with our actual math. And now we get to consider 3 different scenarios. And so what we do in these scenarios is consider when this is less than, when x is less than 1, so that will cause this to be negative and this to be negative. So what we do is we say in case 1, we have a negative times a negative, and that will equal a positive. And then in case 2, we have what will be still a negative, because any number less than 4 minus 4 will still be negative, times a positive, because like 2 or 3 or whatever, minus 1 will be a positive number, and that will equal a negative. And the last one is any number. I just like to plug in like a million and see what the numbers work. Million minus 4 is positive, million minus 1 is positive. So positive times positive equals positive. And what we're looking for is when it's greater than 0, and positive is just another word for meaning greater than 0. So we're going to consider this zone right here, because it has values greater than 0, and this zone right here. So what we're going to do is we're going to make on our graph, we're going to circle these areas, not fill them in because it's greater than, but not greater than or equal to, and then go off in these directions, because those are the zones that it's valid in. And then from that we can turn into, we can, whatever, I forget the name for the notation, interval notation of negative infinity to 1, unioned with 4 to infinity. And that's how you work out just a basic quadratic inequality. But now let's go from 0 to 100 real quickly. Let's see, what will be a good, really hard one. Here's a good one. Because this lets us show off the probably most common mistake made while solving an inequality. Sorry about the video cut off, so I'm gonna start right back here with the equation I had set up. First step that you're gonna want to do, subtract this from both sides, so you have set equal to 0. So you're gonna have oops. And then from this point on, we can multiply both this by x, or well, we can multiply this by x minus 1 over x minus 1, 4 minus x over 4 minus x, because we want to get the common denominator. However, we can do a trick right here and replace this with negative x minus 4, and then we can combine these two negatives right here into a plus. Now this is much easier to work with because I got rid of a negative and I got rid of a minus sign. Then with this separation, then we can do just multiplying the numerator and denominator out. And then we do the same thing over here, but instead of multiplying by x minus 4 over x minus 4, we're going to do it by x minus 1 over x minus 1. Now we can combine these numerators. I'm just going to combine the numerators. I'm going to simplify these numerators and then add them together really quickly. Just that step will just be a basic arithmetic. So, I mean, you can still look. I'll make like a little box this side of where I did it. Alright, so we got this, and so what we're going to have as our numerator is minus 1 over x minus 4. This numerator also can be factored into 2. Oh my gosh, now I'm blanking. Minus 2 and plus 1. I think. Yep. YouTube. And then from here, what we have to do is consider a whole bunch of cases. So I'm going to erase everything that I've done up to this equation right here. And figure out all the cases on a big number line. And we're looking for every spot where this equation is either undefined or equal to 0. If I look, this would be -1/2. This would be 2. This would be 1, and this would be 4, if I'm not mistaken. So we're going to want our points to be -1/2, 1, 2, 4, because we want them to be in order. Then we're going to do our Roman numerals, so we don't get them combined with our Arabic numerals. And now we have a bunch of cases to consider. Let's first consider where we're just doing a really big negative number. So we're going to have negative times negative or negative times negative. And that's going to be equal a positive, which is not what we're looking for. We're looking for a negative. The next one is going to be consider 0 plugged in everywhere because it's between -1/2 and 1. It's the easiest to think about. We're just going to have positive, negative, negative, negative. That's going to be a negative divided by a positive, which is going to be a negative, which we are looking for. So I'll circle this right here. Between 1 and 2. So consider 1.5. We'll have it positive here and positive here, but these two will be negative. So it's positive times negative over positive times negative. Which is a negative over negative, which will be positive, which we're not looking for. And then let's consider the case of 3, because that's between 2 and 4. We'll have positive, 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 and negative. So we'll have a positive times positive over a positive times a negative. That will equal a negative. And then the last one, like the way I like to do, plug in a million everywhere. Positive, 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 positive. A bunch of positives. And well, guess what that will be? That's right, it's positive. Oop, and we'll circle this one since that's what we're looking for. So we know these two ranges are going to be valid, and we have to consider which one of these, what of these 4 points will be valid. First thing to do is consider these 2 points, negative at 1 and 4. Those cannot work because those are spots where the point is undefined. Or since we're looking at less than or equal to, any spot on any point, critical point on the numerator will be defined and will be equal to 0. So we can bubble in -1/2, bubble in 2, and then link these two sets together. And we've got x is a, don't forget that, might get points off. -1/2 to 1, union with 2 to 4. And this 2 right here should be a hard border too. Yep. And that's going to be it for inequalities. Last one up will be absolute values, which I won't go super in depth in because this video is already taken long enough as is. Yep, still recording. So these absolute value. If you go back to my 2.5 notes video, you'll see that you define absolute value as absolute value of x as x when x is greater than or equal to 0, and negative x when x is less than or equal to 0. So let's work with this thing called the case method. It's extremely similar to what we just did with the Roman numerals, and they'll even come back. Roman numerals on number lines, those will come back again. It's more just a different name to the same process. Alright, so we've got this relatively simple looking equation. And what we're going to do is consider all of our cases. And our cases are going to be for any value of x inside of an absolute value where the absolute value equals 0. Because remember, that's when it switches from positive to negative. So we're going to have 1/2 right here. We have case 1 and case 2. Case 1, we're going to consider when this is negative, or well, when this original function is negative, but we can multiply this by negative to make the function itself positive, equals 3x minus 2. So this is going to be negative 2x plus 1, really is what that's going to be, equals 3x minus 2. Simplify this out. Negative 2x plus 1 equals 3x minus 2. Add 3x to both sides. We got, and then subtract 1 equals negative 3. And that's pretty straightforward. Assuming I did my math right, which I don't think I did. No, I'm looking at it. Yeah, because that should be a 5x. That's embarrassing. No, this should still be negative, but that should be a 5x equals 3. I just confused addition and subtraction. That's kind of sad. Which means 3/5 equals x. But, so we got like, okay, 3/5 equals x. We have to consider something. We're only looking at values of x less than or equal to 1/2. Since this is not less than or equal to 1/2, we don't have this equal to 3/5. Instead, this equals the empty set because there's no elements of x that fit that. And we'll do case 2 over here, which is where it's greater than or equal to 1/2, which means we just consider the case where the absolute value is already, where the function inside the absolute value is already positive. So we can just leave it as is. Now we can add 2 to this side, and oopsie daisies. Subtract 2x from both sides. 1 equals x. And since this 1 is in fact greater than or equal to 1/2, this is true, which means we can just say that's our answer. That we're looking for is x equals 1. Because since we have the empty set over here, and what we're looking for is the union of case 1 and case 2 and ... So if you have a bunch of cases, we're looking for the union of all the cases. And the union of the empty sets and any other value will just be that other value. Alright. Since limited time and time for one more question, I'm just going to ramp this up really quickly and go to a hard one. What would be a good hard one? Alrighty, here's a good one. Because this one has a lot of steps. So that means we get to cover a lot of different concepts in this one question. Yep, 5. So first off, we see this double inequality. What our first instinct going to be to do is just ignore everything, split this up. This is 2 inequalities. It's just a notational way of writing it into one inequality. And then we're going to have less than or equal to 5. And so we're going to have 2 cases over here, case 1 and case 2. We're going to have 2 cases over here. And what case that we're working with is going to be x is greater than or equal to 1, or well, x is equal to 1 as the center of the case. I don't know why to look at my notes for that. It's literally x minus 1. So over here, we're going to consider for this range, any value in this range, along with this when it's negative. So 2 is less than or equal to negative x plus 1, because that's just what the negative that is. Then we just add x to both sides, subtract 2 from both sides, and we got x is less than or equal to negative 1. That looks right. And what we can then say from there is, since this, we consider where this matches, and here, less than or equal to negative 1, we can then say for case 1, it's going to be the range from negative infinity all the way to 1. Negative 1, I mean. Because both these go all the way from negative infinity up to a value. It's just this is the smaller value, that's what we're going up to. And then this bottom one that we're considering, where we're considering 1 and greater. It's a terrible infinity. We just consider the equation as is without the absolute value. So then we have 3 is less than or equal to x. And what we can say there is x goes all the way up to infinity, but caps off at 3. So I believe from that we can conclude that this goes from 3 bracket 3 to infinity, which means the left half of the equation is negative infinity to negative 1 unioned with 3 to infinity. And I'll box this because it's starting to get kind of messy. It's a terrible union, by the way. Over here, case 1, it's going to be when it's negative, so again, negative infinity to 1, where we have negative x plus 1 is less than or equal to 5. Add x both sides, subtract 5 from both sides. You got negative 4 is less than or equal to x. And now we're considering where the lower bound is negative 4, upper bound is 1. We'll be able to say, therefore, we have negative 4, comma 1. Believe that looks right. Oh no. Wait. Am I right or am I wrong? I think I'm right. Yeah, I'm right. I don't know why I'm panicking. And then over here we're just considering this case as is. Which is going to be that correctly? I think so. Oh, less than or equal to 6. Oopsie. See, that's why you double check. Oh, this is going to be for the context of 1, 2. You guys can tell I'm getting tired, I bet. So this is going to be anywhere from 1 to 6 bracket. Which means we can say that this area would be anywhere between negative 4 to 6. And now I'm going to, because that's the union of these two, now I'm going to resolve this so we can do the work to finish up the very last problem of the night, which is where we find the intersection of these two. That's done on a big old number line where we mark all these points. We have negative 1, 4, that's a terrible 4, negative 4, negative 1, 3, and 6. And we're looking for where it's going to be both red and green. Those are the colors we're going to be using. Red's going to be over here, And green's going to be for over here. First off, we'll do green. Anywhere from -4 to 6. And over here, -infinity to -1. And 3 to infinity. We can see that these are the areas that have both colors, which allows us to finally conclude that this statement, x is in the set of these should all be brackets, -4 to -1, union with 3, 6. And that would be the end of the algebra review for chapter 2.